All right, we're back for the exciting conclusion to the rose curve worksheet here. We're looking at this one, r equals -4 cosine of 2 theta. If that's a 2 on the inside, then there should be 4 petals on this, right? Because as we learned on the front, it's always going to have 2 times that n value if n is even. So you double that amount, and that's how many petals you should end up with. This is cosine, so it should be a 4-petaled rose curve, which is symmetric with the x-axis, just so you have at least a rough idea, but that could still look a few different ways. And so now how to get those, it's kind of up to you, but our period is going to be 2 pi over 2, which means our new period is pi. So your new increment should be pi over 4, 1/4 of that new period. And pi, 2 pi, amplitude of 4. Four, 3 pi over 4, 3 pi over 2 in the middle there, 5 pi over 4, 7 pi over 4. Okay. You get the hang of these, you can move through them pretty fast. You might find your own little patterns and things also. Maybe you don't have to go through all this, but I find it's at least a good way at the beginning. So period of pi, this is a negative cosine cycle. So at 0, if you're not sure where cosine starts, negative cosine is going to start at the bottom of the trough. You're not sure? Just plug in 0. 2 times 0 is 0. Cosine of 0 is 1. 1 times -4 is -4. But you get that first point, hopefully you're off and running. Then we're on the midline, then off the midline, on the midline, and then back to where we started. So we've got that negative cosine cycle, and it's going to repeat here. So picking right up there, we move to the midline, then the crest, then the midline, then the trough. One more cycle for good measure. Okay, so the very first point is -4, 0, theta being 0, r is -4. So that would be 1, 2, 3, 4 to the left, and not rotating at all. So starting right there. And then as we rotate to pi over 4, our r value is now 0. So we're here. So just that piece alone, if you can picture, we're rotating in the positive direction, so it would be moving in this direction, but r would be decreasing, getting back to 0, reeling towards 0. So you're going to get like a half petal there from that half trough. Then pi over 2, r is 4. So that would be 1, 2, 3, 4 straight up. And you actually get that. As you continue to rotate from there to there, your r value increases. So you actually get another half petal. So you start with a half petal because cosine starts with a half trough, and then a half petal from this half crest, and then back down to 0. That's going to complete the crest, so it's going to complete the petal. Then pi, r is -4, so -4, but then rotated pi is going to put you right here, 1, 2, 3, 4. So between there and there, between here where we picked up and there, you are continuing to rotate. You get another half petal, and then you got it, I'm sure. It's going to bring you right back to the origin. 3 pi over 2 is 4, so 1, 2, 3, 4 straight down, and then back to being 0, and then 2 pi, r is -4, so -4, 2 pi is going to put you right there. So it actually finishes off, it's like the other half of that trough which we started with. So it kind of finishes that whole thing, and there's your 4 petals, so you know you're done, which is another reason why it's good to know. You don't have to go do another cycle. So again, we got a 4-petaled one. It's symmetric with the x-axis and the y-axis for that matter. Notice how it does look a little different than this one. the sinusoidal one we got, was also symmetric with the x and y axis. But look at how they were positioned here. Whereas these were right on the axes. So, you know, a little different, kind of cool. And here we go, one more of these. R is 5 cosine of 3 theta. Again, that is going to give you a new period of 2 pi over 3. And hopefully you realize that is going to be 3 petals because you've got an odd coefficient in there. So whenever it's odd, it's that number of petals. If this were a 5, you'd have 5 petals. Our period is going to be 2 pi over 3, which means our increment's going to be, just like on the front really, dividing that by 4 gives you 2 pi over 12 or pi over 6. And just like on the front, you might start to realize, remember, we didn't need to go all the way to 2 pi, but who knows? You might forget that. So 2 pi over 3, there's where my first one's going to end, then 4 pi over 3, and then breaking that up into quarters, pi over 6, 2 pi over 6, which is pi over 3, 3 pi over 6, which is pi over 2, 3 pi over, that's 4 pi over 6, 5 pi over 6, 6 pi over 6, which is pi, 7 pi over 6, 8 pi over 6, which is 4 pi over 3, 9 pi over 6, which is 3 pi over 2, 10 pi over 6, which is 5 pi over 3, and 11 pi over 6. Just good fraction work, if nothing else, even if we don't end up using all of them. 5, negative 5, it's positive cosine. Where does positive cosine start? At the top of the crest, all right. And then we're off and running. Back to the midline, trough, midline, crest. There's your one complete cycle. Midline, trough, midline, crest. There's my second cycle. Midline, trough, midline, crest. There's my third cycle. Yeah, I got a little scrunch as I went along. So first point, R is 5, theta is 0. So that's going to start 1, 2, 3, 4, 5. Theta 0, so staying right there. Then back to the origin. So there's a half petal, but can you tell where that half petal is? Is it right there or is it right there? And it's right here because you are rotating from 0 to pi over 6. So picture starting from this and rotating in the direction of pi over 6. That's why you're going this way. You're going this counterclockwise way. And then R is getting pulled back to 0. Then pi over 3, R is negative 5. So 1, 2, 3, 4, 5 to the left, and pi over 3 from there would put you right here. Or again, here's your pi over 3, but going 5 backwards along that line. And so that is going to give you that. And it's really like a, I'm not doing it justice here, it's going to be like a complete nice smooth curve, and then back to the pole here, back to the origin. R is 5 when theta is 2 pi over 3, so that's 2 pi over 3 is this line right here, 1, 2, 3, 4, 5. And so you kind of, if you draw these, instead of drawing them piecemeal like I've been drawing them, if you draw them in one continuous curve, you really get this nice, beautiful swoop. It's not these, jagged, disjointed things I've been drawing. But, it's hard to do that on your first day or your 20th year, whatever it may be, like I'm doing. 5 pi over 6, we're back to 0, so it just pulls it right back to there. Pi, R is negative 5, so pi is in this direction, but 5 backwards is going to put you right there. And I think you have a sense that now you're done, because there's your 3 petals, and we're only supposed to have 3. But if you want to keep going, just to make sure you're tracing along that, 7 pi over 6, okay, that puts you back to 0. Then 4 pi over 3 is 5. 4 pi over 3 is 5. Well, 4 pi over 3 is this line, and 5 units out, we're right there. We got the whole thing. So the whole graph just goes like this. Just over and over and over again. Pretty cool. Check it out on your calculator or on Desmos if you like. And of course, this is where you can really get funky. And if you make these, non-integers on the inside, and then you start putting plus theta on the outside, plus theta squared, that's when you'll start to get all kinds of weird spirals and funky things like that. Not going to have you draw those. If you take BC Calculus next year, you'll be doing some things like this will represent the motion of some particle, and you'll find the area inside one of these, petals. And so a big thing is always to know when does it hit the origin, and so that's when r is 0. So, just good to know about those basic properties here. But hopefully you enjoyed these graphs. They're pretty cool. You got the limacons, the rose curves, and the basic lines and circles we did on day 1. And tomorrow we'll do a little practice with all of them mixed up, hopefully. Hopefully you're feeling pretty good about it, though. All right, as always, hit me up with any questions, and just hang in there if you're finding it tricky. Take it easy, kids.